Namaste to everyone. I welcome you all in my YouTube video channel. Today, I will deliver lecture on Pigeonhole Principle, lecture number 4, in which I will solve some more problems on Pigeonhole Principle. Now, we solve a problem. Problem is find minimum number of elements chosen from 1 to 12 such that 2 of them will add up to 13. Now we solve this. Firstly, we construct all possible set of the type a set containing 2 elements x and y. These elements are chosen from this set S. S contains elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 such that x plus y equal to 13. Then such type of sets may be formed as S1. S1 equal to a set containing elements 1 and 12. 1 plus 12 equal to 13. Similarly, S2 equal to a set containing 2 elements 2 and 11. 2 plus 11 equal to 13. Similarly, we get 6 sets in which sum of 2 elements be 13. We may say that these 6 sets constitute partition of the set S. That is, Si intersect Sj equal to 5 means intersection of any two sets equal to 5 and union of all sets equal to S. If we choose one element from each Si, we get 6 elements. If we take one element from S1, one element from S2, one element from S3, one element from S4, one element from S5, one element of S6. Then we get 6 elements. And we may also check this sum of no such 2 elements be 13. For example, if we take 1 from S1 and 11 from S2, 1 plus 11 equal to 12, not 13. Similarly, if we take 8 from S5 and 6 from S6, 8 plus 6, 14. So, we will not get sum 13. So, we will have to choose more elements than 6. Then our purpose will be solved. Let number of elements to be chosen equal to n. This may be treated as number of pigeons and number of pigeonholes be 6. Here 6. Here we see that this set is set of pigeons means numbers and this set containing 6 pigeonholes. Let n1 belongs to S1. One element is taken from this, and without loss of generality, let image of this lies in H1. Similarly, N2, image of N2 lies H2. N2 is taken from S2, and in this way N6 is taken from S6. Here let we take one more element in 7. Therefore, we get 7 elements. According to the pigeonhole principle, one of the hole must contain at least 2 pigeons. Let N6 be 6 and N7 be 7. Then 6 plus 7 will be 13. So, in this pigeonhole, we will get 2 numbers such that their sum is 13. So by pigeonhole principle, we get greatest integer function n minus 1 by number of pigeonholes 6 plus 1 equal to 2, implies that n minus 1 by 6 greatest integer function equal to 2 minus 1, implies that n minus 1 equal to 1 multiply 6, implies that n equal to 6 plus 1 equal to 7. So we will have to choose minimum number of elements 7. Therefore minimum number of elements to be chosen equal to 7. Now we solve the next problem. Problem number 6. Find minimum number of elements chosen from 1 to 9 such that 2 of them will add up to 10. Now we solve this. This is similar to the previous problem. Firstly, we construct all possible different sets of the type. This set contains elements of type x and y. These elements are taken from the set S. S contains elements 1, 2, 3, 4, 5, 6, 7, 8, 9 such that x plus y equal to 10. This type of sets are S1 containing elements 1 and 9, 1 plus 9 equal to 10. S2 contains elements 2 and 8, 2 plus 8, 10, and similarly S4, 4 plus 6 equal to 10. And again we repeat these sets from S1 to S4 and we get another set S5 which contains single element 5. Because in these sets we do not get 5 as elements. So here we get 5 number of sets. These 5 sets constitutes partition of the set S. Partitions means intersection of any two sets equal to 5 and union of all sets equal to S. If we choose one element from each SI here, these partitions, that is we will get 5 elements and no two elements among these 5 elements will give the sum 10. For example, if we take 9 from S1 and 2 from S2, 9 plus 2 equal to 11, not 10. Similarly, 2 from S2 and 7 from S3, 2 plus 7 equal to 9, this is not equal to 10. So we will have to take more than 5 elements so that our purpose will be fulfilled. Our purpose is we will have to choose 2 elements such that their sum is 10. Let we choose number of elements equal to n. These be number of pigeons and here number of pigeonholes be 5. Here we have 5 sets. If we take here 5 elements without loss of generality, let n1 belongs to S1, n2 belongs to S2, n3 belongs to S3, n4 belongs to S4 and n5 belongs to S5. Here sum of no two elements will give 10. Let n1 belongs to H1. Here number of elements be 5. If we take here more than 5 elements, then according to the pigeonhole principle, 2 pigeons will lie in a pigeonhole. Let n1 lies in H1, N1 belongs to S1. Then if we get here also 9, then 1 plus 9 equal to 10. So we will have to take more element in 6 that may belongs to S1, and this pigeon will be in H1 whole, and 1 plus 9 will be 10. Now by pigeonhole principle we may solve this. By pigeonhole principle, number of pigeons n minus 1 by 5 greatest integer function plus 1 equal to 2 implies that greatest integer function of n minus 1 by 5 equal to 2 minus 1, and n minus 1 equal to here 1 multiply 5, and n equal to 5 plus 1 equal to 6. Therefore, minimum number of elements to be chosen equal to 6. Now, we solve the next problem. Problem is, so that at any party with 6 people, there either exists a set of 3 mutual friends or a set of 3 mutual strangers. Now, we solve this. Let X be a person in the set of 6 people. Let S1 be the set of persons who are friends of X, and S2 be another set of persons who are strangers to X. Since total number of people equal to 6, therefore excluding X, number of persons equal to 6 minus 1 equal to 5. Among these 5 persons, some will be members of S1 and remaining will be the members of S2. Let these two sets be compared with pigeonholes and 5 persons as pigeons. Therefore, number of pigeons equal to 5. Number of pigeons whole will be 2. Therefore, according to the pigeonhole principle, we get greatest integer function 5 minus 1 by number of pigeonhole 2 plus 1 number of pigeons will be in a pigeonhole. If we calculate this, we get 3 number of pigeons will lie in a pigeonhole. Here pigeonholes are S1 and S2. Here either in S1 there will be 3 persons or in S2 there will be 3 persons. Let these persons are A, B, C. Number 1. If A, B, C belong to S1, since S1 be the set of persons who are friends of X, if these 3 persons belong to S1 and if 2 of them are friends, for example A and B are friends, since the members of S1 be friends of X, here A and B are friends and these 2 along with X, that is 3 persons, will be friends. It may be possible that A and C be friend, then these 2 along with X, that is number of 3 persons, will be friends. If no 2 of them are mutual friends, then all these 3 will be strangers, that is 3 persons of S1 will be strangers. Number 2. If A, B, C belong to S2, S2 be the set which contains strangers to X. Let 2 of them are strangers. Then these 2 along with X means 3 persons will be set of strangers, means three persons are strangers. If no two of ABC be strangers, then they are three mutual friends. Therefore, set containing elements A, B, C be a set of three mutual friends. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.